All right. And so we're going to kind of continue. Okay, yesterday, when you guys talked with Eli and everything like that, again, he gives some great information. He does all right. Sometimes he's a little older, so he kind of goes on and on, kind of goes away and doesn't really talk about the same stuff. He's aging. He just has that difficulty. But so I think maybe yesterday was supposed to be about section 4. Today's about section 5. I'm going to kind of combine a little bit together just so we can get a little bit of bits and pieces. So we can talk about section 4, which is mostly focused about NumPy, which will be really important when we talk about Pandas, which is really going to be our go-to tool as a data scientist. It's just a really useful thing. It's not necessarily the best tool for every data science project, but it's usually like the first thing we use. And then as we get more advanced tools, for example, we use things like PySpark to process big data, like data sets and stuff like this. We can still use Pandas to do a subset of that and kind of explore a little bit and get an idea before we move into something more advanced tool and stuff like that. Okay, so I'm going to share my screen and you'll see me a little bit. These are a little bit mostly notes to myself, just so you know. But I'm going to work off that because it's just going to be a little bit easier for me to make sure I get all that organized. All right, cool. So no, this is not a notebook that you have to worry about. I just kind of taking notes about here, but what you guys went over, all that stuff. So, all right. So I want to talk about, we're going to basically focus most on intro NumPy first, and then we'll see what time we have for like the rest of Pandas. So let's go ahead. And this is all in the repo already. So you can see here, coding basics, NumPy. So if you go into repo, oh, no, this is on the version 2 curriculum branch, 2.1 curriculum branch. So no, that eventually merge into the master. But if you then go into, coding basics, and then NumPy, and then we're intro to NumPy. So we'll start there. So quick thumbs up. Who's already on section, or who's gone through section 4? Awesome, cool. All right. So I'm not going to spend too much time. If you guys have more questions, definitely stop me, but I'll just breeze right through this. So NumPy is just another package that you can use in Python. You can think of it like extensions to Python as packages, depending on your familiarity and stuff like this. So note that we do imports and stuff like this. So, you might have already seen this a little bit done in the labs and stuff like this, but note that we just import the package right here. And then we typically, in data science, we'll have specific shortcuts. So instead of doing like import NumPy, we'll do import NumPy as NP. So NP being like an abbreviation. So we don't have to keep saying NumPy or some really long package name and stuff like that. We'll also do something similar with Pandas. So I'll say Pandas, I guess it's Pandas, but I always say Pandas because in my head, that just means it's something different from a panda. I don't know, but we'll import this usually as PD. Okay, so one thing to kind of cool, we'll talk about Pandas later today, but Pandas is really like an extension to NumPy, which is pretty cool. So it means that if you're familiar with NumPy and understand how to use NumPy, you can actually do a whole lot of cool things in Pandas. And what is nice is that when we get into things like deep learning and stuff like this, deep learning uses like you can use the NumPy structure to do a lot of the manipulations. If you understand that, oh, hey, I can use I can do all my analysis with Pandas and basically feed my data set through as a NumPy array into do deep learning and stuff like that. So again, really useful to realize they're basically the same thing. Or not the same thing, but Pandas is an extension to NumPy. So NumPy, what do we do with this? So one thing to note is that NumPy basically it's like a souped up version of Python. Usually you hear NumPy, like numbers. When I was doing computational physics, that was my big exposure to NumPy, was because it's like, hey, Python's great, but NumPy allows you to do something a little more efficiently. I won't go into the full details, but I will suggest, and I'll talk about this book in the future too, the Python Data Science Handbook has a great I'm just gonna look it up. So it has a great section on NumPy and Pandas all together. There we go. So I'll send this link. And what I love about this book, I'll send this on the Zoom chat so you guys all have this, is that this book is actually completely freely available online, which is a super huge plus. One is that you don't have to worry about spending more money. Of course, if you feel like you like the book, support the author. Jake Vander Plas is actually a really great data scientist. He's very big on open source, which is why he makes this thing available. But what I really like about it being online is that this is going to make it easier to, if you ever have a quick question about Pandas or NumPy and data science stuff, you can very quickly look at this stuff. So for me personally, I will constantly look up the data science handbook to look up like matplotlib with this like visualizations and stuff like this, because it has a really great resource for this. But I would say is that this guy, I usually recommend this to everyone who's starting in data science, but I even recommend to people who are already in data science, because again, it's just a great free resource that is online that you can look up very quickly. But especially like you can look at this stuff right here, like from IPython chapter 1, chapter 2, NumPy, chapter 3, and then chapter 4. This right here, this full section is basically all we're gonna like, after next week, we basically would have covered most of these parts. This obviously has a little more detail and stuff like that. So I think, again, it's a great read. Don't feel like you have to read all of this and understand all of it at once, but it's a good review too as we get kind of further into the course. Okay. But I will point to, there's an introduction to NumPy here, and he goes, Jake Vanderplas does a great job of really explaining about like what NumPy is, like how it works and stuff like this. He doesn't go through obviously all the different like parts of NumPy, but I would say like if you were to read all of that section on NumPy, you would have a pretty good feel of like what you need to know to get through most of like maybe 99% of all the stuff you would bump into in NumPy. So again, a useful section here. But this is my little subsection of that. Okay, so one thing to know is that like we have things called arrays in NumPy. So an array, basically, you can think of it as the equivalent to like an advanced version of a list in Python. So again, there's more, like I highly recommend the Python data science book to really talk into detail. But one big thing about a list in Python and is basically the way it sets up in the computer, its memory and stuff like that. Basically, if I'm gonna really like dumb this down in the sense that like it's not completely accurate, but it's close enough, is that a list is kind of like each one of these numbers in a list, so you can see right here, is kind of like its own little box. And then instead of having all the boxes all lined up, so you can see like in this very first box is the number 1, and the second box is the number 2, the third box, number 3, and so on. Instead of having the boxes all nice, neatly lined up in front of me, I have the box, you know, over here, another box over here, another box over here, another box over here. And someone says to me, you know, hey, give me the second box. I have to go, oh, second box, that's over here. And I have to go grab the one over here. Versus if they were all nice line, I could kind of count them off. A question, yeah.
That sounds like a linked list, no?
It's kind of like that, but it's not quite. It's just, I'm kind of getting an analogy to like how it's set up a little bit. It's more like about the actual memory and stuff. I actually think there's a great, if I remember this, let's see if I can find this real quick. I think okay, this is actually a great idea, example of this. So basically we have a Python list. Don't worry about what these numbers are. Basically, they're just spaces in memory. And this Python list basically says, oh, here's the list of stuff. And you can say, oh, here's all the different parts. But you can see kind of like it's all crossed over in different places. Each of these guys basically represent like what's being held in the first position, the second position, the third position. Versus a NumPy array on the left here, you'll see that it has still the same thing that points like the NumPy array points to this element. But it's almost as if instead of taking all like the list, you know, scattered, like all the different boxes scattered about, it lines them up in this nice little line on the shelf. And you can say, oh, give me the second one. You're like, boom, second one, you know, give me the fourth one, boom, fourth one. What's also really cool is I kind of imagine when you apply functions to a list, in order to apply a function to a list in Python, you essentially have to say, oh, imagine like I have some kind of machinery that does something to a box. Say, oh, I have to apply this machinery on this box. Okay, give me the second one. Oh, it's over here. Apply the machinery over the box. Oh, it's over here. The third one, apply it to the machinery over here. Versus a NumPy array, because they're all in a line, it's almost like I can just go like, almost at the same time, just get multiple machines and apply it to every box at the same time. So it's very, very quick versus having to like look for the box, apply it, and then move on to the next box. So what you'll see is NumPy arrays go very, very quickly.
So you're basically saying that with a regular Python list, it's a list of references that can reference memory in all different places. So it's not nicely lined up. So what you're saying then is that with NumPy, instead of a list of references, I guess you get your list is all in consecutive memory locations.
That's exactly right. And that's exactly what's happening. And unlike the lower end is that it's actually just the same memory space all the way through. And the reason why this happens is like, well, okay, like why would we in Python allow you to do this? Like this seems really kind of like, it's like, if this is so much better, why not doing this? Lists are very flexible. You can put whatever you want in a list. You can put a string and a number and a function in another list within a list. So it means it's very flexible. NumPy arrays are very rigid. It's like, oh, you need to know how big they are, what's going to go inside it, because it needs to basically figure out how much space to keep for each box. Versus a list, you can imagine different sized boxes. So you can put the different sized boxes into different places. So that's kind of the trade-off. And that's, oh yeah, go ahead.
Arrays can't hold multiple data types, right?
Oh, I'm sorry?
Arrays can't hold multiple data types, right?
That's right. There is one data type in that whole array. Okay, cool.
And that's what makes lists different, right? Because they can hold references to any data type.
That's right. It's very...
Yeah, because they're just holding memory, and memory can contain anything.
That's right. And that's what makes Python lists very flexible. But the trade-off for flexibility is speed, where NumPy is less flexible, but it's much faster in general. Okay. So that's kind of like a quick little why lists are different. So it's like, okay, cool. NumPy arrays sound awesome for some things. Let's try it out. So a basic way to make a NumPy array is basically have NP, which basically is standing for NumPy. Remember, we reported as NP over here, dot array. So this basically is going to create an array, and we can actually pass in different elements in here. And for the most part, you know, if you wanted to create an array out of a list, you can just simply pass in a list, and NumPy will basically take care of it. So if I go ahead and run this now, I'm actually going to try to show you guys something different first. Let me go ahead and take this out. So let's say L equals this guy. Oops. So this is just a list, right? And there we go. If I run this now, you can see there's my list, 1, 2, 3, 4, 5, or 0, yeah, 1, 2, 3, 4. I can also take that same list. I'm just going to put it as a variable. So now I could have also listed the whole thing out, and I can create an array out of that list. So note that when we do a dot display, it'll actually show you array to say, hey, this is not a list, it's a NumPy array. So note there's a difference here. Note, however, if I put print in front of here, oops, spell print right first, you'll see that it looks the same, right? In fact, print, and there's actually, when we just put like L down here, and I just run this, what this is really calling is calling display. Wow, I cannot spell today. No, I spelled that right, right? Yeah. Okay, you can see it looks the same, right? Like, oh, it does the same thing. Well, it technically doesn't, because if you see here, if I do print my array, and I do a display of my R, you'll see that print will actually print out what almost looks like a list, but there's no commas in there. While display is a little more explicit, saying, hey, array, and then showing the list. So note that there's a little bit of difference. So if you're trying to print something out versus display. And note that display is what's called, if you just leave the very last part here open, it'll call display on that part. And that's why you see this. Okay. Does that make sense to people, the difference between a print and display? Cool. So this is how you can identify, like, oh, this is a NumPy array when it's printed out. Okay. So we can also do other things. We can actually feed in our NumPy array, you know, create different NumPy arrays using not just a list, but we can also do things like a range. So remember, range was a generator, and that's going to go like 0 through 9. We can actually make a NumPy array that way. So I'm actually going to split this up so I can quickly do that. You can see here, it actually goes to 0 through 9. It's like, oh, that's what we expect, right? You can also do things with tuples. So a list or tuples looks kind of similar to a list, right? So you'd expect, oh, we'd get something that as if we passed it as a list. So you should get 5, 2, 3. And sure enough, that's what we get. Okay. And of course, we can also do, and later on we'll talk about pandas, a series. And we actually pass this through here. Series kind of looks like, I'll just kind of show you guys what a series looks like. Yeah. There we go. Oops. So you can see a series basically is a list of numbers like this. It's got a different kind of structure, but we can also pass in that into a NumPy array, and now we can turn it into a NumPy array. Quick fun fact is that a series really is a NumPy array. It's just got some extra fluff to it, but really it is a NumPy array. That's why it's able to transfer it over. So note that you can create NumPy arrays in many different ways. Okay, sound pretty good? Hopefully that's all review, yeah? Cool, any questions? All right, so I'll try to go through this a little bit faster, so I know you guys are, this is mostly review for most people, right? So remember for the list, right, if we have a list like this, if I try adding to the number 4 in here, not gonna work, right? It gives me an error. But if I wanted to add, like append to that list, I can add two lists together, and that will give me a 4th element on that list. I can also do multiplication. Does anyone know what multiplication does? If I do list 0, which is just 1, 2, 3, if I do times 3, does anyone know what?
Yeah, just repeats
how many copies.
it repeats the elements.
Yeah, it's kind of, it's almost like saying, you know, 1, 2, 3 plus 1, 2, 3 plus 1, 2, 3, which we know would end up being a big list, right? So that's kind of like what this multiplication is. Does anyone know what division would do?
Divide the list.
Yeah, maybe divide the list, right? Maybe put into
It's
3 parts,
right?
right? Or something like that.
I think that's
Yeah,
right.
turns out, no, that's a good guess, right? It kind of makes sense, right? It doesn't work. It turns out it's just, oh, it doesn't know what to do. And that's because we can't also subtract a list. So for example, if I do like list minus 4, it kind of doesn't know what to do with that. It's like, does that mean to take out the 4? Like, we're not subtracting the list together. It's like not quite what you want. Depending if you're familiar with this, you might think that this would multiply 1, 2, 3 by 3 each time. And that's, you know, you can kind of think about that. It's like a lot of times in like math, that's what we want it to do, right? But that's not really what list half do. So you can kind of see we can add lists together like this. You're like, that's not really one. If I want to instead go 0 plus 3, 1 plus 4, 2 plus 5, I have to write a for loop or a list comprehension to basically do all these parts for me, which is kind of a pain. And remember, it's a little slow to look up each number. So NumPy arrays are super great at this because NumPy arrays basically treat things as vectors. We'll go into more detail when we talk about linear algebra, but basically you can think of it like a list of numbers where you have a, yeah, I'm gonna skip over this, never mind. I was gonna tell you what a vector is, but basically, we'll talk more about this. But basically, NumPy arrays are acted a little bit different from lists. So the list itself acts as if it's like this object that has to be appended and stuff like this. The NumPy array actually allows us to do mathematics on it and stuff like this. So if I have this NumPy array, you can see 0, 1, 2, 3, right? I can actually do each one of these things. I can add 3, I can subtract 3, I can multiply by 3, I can divide by 3. And what each one of these things will do will actually apply it element-wise. So it actually will apply plus 3 to 0, 1, 2, and 3. So I should get 3, 4, 5, 6. So if I just go and split this up so we can actually look at each one, you can see 3, 4, 5, 6. And we can see the rest of these if I run this. You can see it subtracts each one by 3, multiplies each one by 3, and then divides each one by 3. And note that it's pretty smart to say, oh, it is now float numbers versus integers. Okay, cool. So here's the kind of similar situation we had up here, which we had 0, 1, 2, 3, 4, 5, put them together, we got this long list. Not maybe what we wanted, right? If we do this with NumPy arrays, as you probably can guess now, it's not going to do the same thing. It's actually going to do something very different, which is going to be basically adding each element to each other. So we'll get 0 plus 3, 1 plus 4, 2 plus 5. So we should get 3, 5, and 7. If I do this, there we go. Oh, it's a little confusing because I have it printed out twice. But if I do this guy like this, you can see each one, 0, 1, 2, 3, 4, 5, and I add them together, 3, 5, 7. Okay, cool. Any questions on any of this math stuff we did at NumPy arrays? Okay, cool. So here's a question. What do you think happens if I do this? So I have 1 with 0, 1, 2, and 3, 4, 5, 6. What happens if I add them together? Anyone got a guess?
Broadcast.
So broadcast, good. So some people know about NumPy, it's not broadcast. Anyone else? Okay, so let's see what best thing to do is just try it out. So it turns out it actually gives us an error because broadcast, it's a little more advanced part. Broadcasting basically says like, hey, is there something missing here? I'm gonna go ahead and fill that in for you. NumPy doesn't really know what to fill it in with. It's like, hey, it's a little too vague. So basically it's like, oh, I can't do this. Note, however, like Alvaro had mentioned, you can do something called broadcasting and NumPy will try to figure it out for you. Say, I think I know what you meant, so I'm just gonna go with it. But it might not always be what you meant. So be kind of aware of this, but you shouldn't be able to add these two together. Okay, and you can see it in the broadcast together with these different shapes. Okay. Cool. Let's see if I actually try it this way. I think I can actually do this. No, can't do it that way. Okay, so let's move on to multidimensional. So just like we can have a list of lists, we can have a NumPy array with more than one, just one long string of numbers, or I shouldn't say a string of numbers, but a long list of numbers. So you can see here I have basically a list of lists. So this is a big old list, and each element in that list is another list of 3 elements like this. And I can actually run this now, and you'll see now that this array now is a 2-dimensional array. In fact, you can see here, it actually has a nice little structure in this. In fact, it's like a 2-dimensional like set of numbers. You can see here I have 0, 1, 2 in the first row, 3, 4, 5, and 6, 7, 8. Okay, so we can also do, you know, really complex stuff. So you see here range of 0 to 3. So note that I can do range thing. Oh, go from 0 to 3. So it'll be 0, 1, 2. And then this one will be 3, 4, 5. And this will be 6, 7, 8. if I got that right. And so you can actually have these big parts here that can actually make this big old NumPy array. So this is actually a 3D array here. Okay. So, and you can kind of see here is that basically this whole big list, if you imagine it as a list, it's like this whole big list, each one element is this whole thing. And then each one of these things in here has their elements are a separate row. And we'll go into more detail about this when we talk about using NumPy arrays in linear algebra, but know that basically you can create multi-dimensional arrays. Okay, does that make sense to people? Cool. All right, one thing to note, if I put in, like let's say I have 4 elements here, 3 elements here, it does not like this. And note that NumPy goes, oh, like you can see it does something very different. It's making now a NumPy array. Remember, this is still a NumPy array. And then we get these list elements in here. It's because NumPy has to say every element in my in my array has to be the same, like has to be the same type. The problem is, it's like, look, each one of these things, like you can imagine when it was just 0, 1, 2, each one of these are going to be an array of 3 elements. And so each row will be an array of 3 elements. The problem is if there's 4 elements in here, it's like, I can't have each item being an array of, 3 elements, 4 elements, it doesn't know. So it basically just defaults and says, I'm gonna give you a range, or sorry, not a range, a list. So each element now is an actual list. So note that there's a little bit of difference in there. Okay. So again, a lot of nuances in NumPy and stuff like that. There's even more that I could probably go into, things that I probably don't even know. But it's important to kind of just notice a little bit like how these things work. Okay. So one thing to note is we can also get this shape. So the shape basically is kind of like almost like how many elements are there in there, but a little more broad than that. So for example, if I were to do something, let's say if I have like a list of lists like this. So this is a list of lists, right? Okay, if I do len of L, what's this number gonna give me? 3, right? I actually make it a little bit harder first. Let me go ahead and put in like an extra element in there. All right, now what should L give me?
4 by 4. 4 by 3.
So I hear 4 by 4. I see some people giving the number 4. Some people think just the number 4. Some people say it should give me something else. You said maybe 4 by 4.
I think it was by 3. I mean, by 4, 4 by 3.
Or 4 by 3. Okay, so if I actually run this now, it'll just give me the number 3 because there's only 3 elements in here. Okay, and then you can think of it as just being like 8 elements in there. If I wanted to see how many elements are in here now, I could do like len of L0, right? And that should give me the number 4 because it's, oh, the first element has 4 elements in it. So you can notice like, oh, if I wanted to know what the shape of the list is, it's not super easy to like understand like, oh, it's like a 3 by 4 or 4 by 3 or 3 by 3 or whatever. So you can see here is that, well, we can actually do something in NumPy. We can call something called dot shape. And so this array 2D, I don't even remember what this looked like. Let's just kind of put this in together. Oops. So if I go ahead and run this, you can see, okay, this is like, it's 3 rows with 3 elements. So if I run dot shape here, you can actually see it says 3 rows with 3 elements in here. If I went to, let's go ahead and try to do this. So let's do np dot array of L, right? So we should see now, you can see it looks like this guy. So if I do this shape here, you'll see these numbers change. So you should see it's still 3 rows, but 4 columns in each. So it can give this shape. This also works for 3D shapes. Remember this whole 3D thing? This should actually give us a tuple of 3, 3, 3. Sure enough, that's 3, 3, 3. Okay, so this is a really nice way to basically pull up, we'll talk about shapes. And I'll tell you is that in Pandas, when we talk about data, every column, essentially, we're adding more dimensions to it. So you might have something like a 3 by 5, or we might have multiple dimensions like this, like 3 by 3, or even like 4 dimensions. Again, we'll talk more about this in linear algebra stuff when we get closer. But know that we can basically pull up what the overall shape is. And if I wanted to know how many elements are in this, how many elements are in this R3D in here? The whole numbers. I saw 3, so but like how many total numbers are there? You might have to unmute yourself on this one.
3 times 3 times 3, 27.
27.
27, yeah. And so all you got to do is just multiply each part. 3 times 3 times 3 would give you 27. And you can see here, they counted us all out. right? There's 9 here, 9 here, 9 here, 9 times 3, 27. Okay, same thing here. There's 12 elements, 3 times 4. So we can see 12 elements in total. Okay, so that's kind of a quick way for us to like see how many there are. Okay, cool. All right. So any questions on anything I went over for NumPy so far? Sound pretty good? Thumbs up, thumbs down, sideways, understanding? Okay, all right, yeah, I see some sideways, that's okay. There's a lot of practice to do, like I totally understand that. All right, so I'm gonna go through some built-in functions and stuff like this. So some built-in things that we can do. We can actually build up arrays of certain like shapes and different kind of things. So one thing is called zeros. So we can actually create an array of zeros here. And you can see here, basically, this is a shape of 3, 4, 5. So you can see here, there's basically 3 different, what we'll call like matrices, right? So 3 different matrices. And then each of these matrices has 4 rows and then 5 columns. So you can see, I can very quickly do this. I could also make it simpler, like, okay, let's do like 3 rows and 5 columns. You can see this guy. So it can be really useful if you just want to make a bunch of zeros, essentially. We can do something very similar, as we saw with like 3, 4, 5, right? If I do np.ones, anyone got an idea what this would give me? Yeah, a bunch of ones, right? Like, makes sense, right? It's like, okay, cool. All right, fool. Now, fool's an interesting one. And you can see there's a little hint here, is I got 3, 4, 5 like before, but I also have a second element, 27. Has anyone got an idea what np.fool will do? Like, what will this look like?
A bunch of 27s.
A bunch of 27s. There we go. Okay, yeah. So you can see here, it's like, all right, this is not too bad. So it makes a full, like, you know, whatever you want of whatever that number is. This is an interesting one though. Full, and I have 5, right? An NP range of 5. So what does range of 5 give us? Like if you were to convert this into a list, what would that look like?
0 through 4.
Yeah, 0, 1, 2, 3, 4, right? So we have np.full, and we say, okay, there's gonna be, we saw this is the shape, there's gonna be 5 elements in it, and a range of 5. Well, that will actually just give us just an array of 0, 1, 2, 3, 4. So you're like, oh, cool, like awesome, right? Like we should be able to then do something like this, right? Say, okay, what if we give like a full of this guy? Unfortunately, it doesn't work for multiple dimensions, but you'll see this typically be used a lot. But just kind of be aware that it doesn't quite work out. And there's full documentation, of course. If you do your Shift Tab, look it up, you can see a whole bunch of extra stuff about what you can do and things like this, as well as some examples. Oh yeah, do you guys know that NumPy actually has infinity built into it? Yeah, so that's nice. NumPy.infinity, and you're like, what does that mean, right? Well, NumPy infinity is always greater than any number. Like, so it's a really useful thing. There's also negative infinity, which I think you can just do like this, if I remember this right. Yeah, so negative infinity goes in the opposite direction. Again, a useful thing, since Python, we can't really write infinity. Okay, cool. Any questions? Anything we've been over? Sound pretty good? Cool. All right, slicing and dicing. So this is kind of a fun stuff. So we can actually do some interesting other ways to create NumPy arrays. We can actually manipulate the arrays and change different elements and grab certain elements. So this R0, you can see np.random.randint, low 0, high 10, size 5, 8. Someone, before we even run this, maybe you've never seen this or done it before, what do you think this is gonna do? Someone wanna try to walk me through this?
Isn't it going to put in random numbers in an array that's 5 by 8 with the lowest number being 0 and the highest number being 10?
Perfect, 100% right there. And you can see here, that's exactly what happens. You can see the lowest is 0, the highest, well, in this case, we don't include 10. Usually when we say from the bottom to the top, we won't include it, but you see the highest is 9. And you can see it's random. So to prove it's random, I can run it again. And you can see new numbers every time, okay? So you can also put in here, and we'll talk about this in, oh, I can't actually put this in here. You can set what we call like a random state and actually get the same number every time, but we'll talk about that in the future when we talk about probably statistical distributions. We'll talk about using, yeah, well, yeah, you can think of it as seed, yeah. So you can also call it, like we call it state or a seed, basically the thing that you start off with, so you always get the same random numbers, which is kind of a misnomer. But anyway, all right. So anyway, that's how we can create a bunch of random numbers, okay? We can also get specific rows. So I'm gonna split this up so we can see this first part, our first row of R0. So we should see the first row. We can get the first row here, which will be 7, 4, 2, 3, 5, 6, 1, 9. Perfect, right? If I wanted to get the first element of the first row, what do you think we could do? How could I
0,
modify
0.
this code?
You put another list in the thing, yeah, and a 0.
Yeah, another bracket, right? The square bracket. And you can see here, first element in here. And you can see very similarly, if we do -1, we get the last element in there. Ah, look at that. So you can see, just like this last row, I can get the last row, like this guy right here. I can also get multiple rows. So you can see here, I'm going to get the second row, starting with number 1. And then this part right here, which is going to be up to number 3. So it should stop right there. You can see here, I get 197,69752, and then the other row. I don't want to read all those numbers again. Okay, pretty cool, huh? All right, you can also do the same thing. Like, it's like, okay, I want to do this part. You can see this is a NumPy array, right? I can say, what if I just want to get the second element and the third element from each of these parts? So I want 9746. I can just go ahead and do this and say I want the first element and I want up to the third element, right? So it's not going to include the, sorry, not going to include the fourth element in there. So if I do this now, it didn't quite work there, right? And that's because it did actually work in there, but we're actually pulling this up right here. And what's happening here, we're actually getting these first few parts in there. So you also have to be very careful about how you slice and dice your numbers and everything. Okay, cool. All right, so then you can see I can do some really fun stuff here. I can actually row start to 7. So this is actually, I actually want a subarray. So the kind of an array within an array. This is the way you should actually do this. So note that row start end equals 2, 7. Have you guys seen a format that looks like this, where you have multiple variables equal to the other side? Okay, so what's really going on here is something called pattern matching. So what I could have done is row start equals 2 and row end equals 7. Okay, that would have been the equivalent to this guy, right? What's really happening here is that I'm doing a shortcut. Python knows that when I put a comma between, that really means a tuple. And so it's saying this tuple of row start end is equal to this tuple, 2, 7. And so what happens here is that if I go run this guy now, I'll just show you guys separately. If I do row start, you can see, it's gonna be 2. And if I do row end, you can see it's 7. So this is a really easy way for us to quickly get numbers. Be careful about doing this. Just don't make it super complicated where you're doing a whole bunch of numbers all in once. Make it readable. But in general, you'll see this kind of like syntax used. Okay. So what this will do, basically, this will get us those specific rows where we start from the row second row to the 7th row, and then the column end from 3 to 6. So I run this guy. You can actually see again 92. I should probably show you guys what R0 was, huh? There we go. You can see here I get the second row right here. Oh, I guess I don't know. I put 7 here because it will continue on past 7, right? But you can see it from second all the way to the end here, and then it's just getting the columns, which is the third column, or it's the fourth column. So 0, 1, 2, 3, right? So that would be right here. So you see 901. We see 901 up to the 6th column, which will be up to here. Oh, I lost my place right here. 2, 2, 4. So you see this guy right here is really just, I can't really highlight this well, but these guys. Okay. So a way we can make a subarray. Sound pretty awesome? Sound good? Cool, awesome. All right, how are we feeling with NumPy? Thumbs up, feeling pretty good. Thumbs down, like, oh, it's still confusing. Sideways, like, I think I got this, but maybe some practice. Okay. All right, I see sideways, some sideways. I like to say, so when I see this kind of thing, I think it's like, oh, it's really this. But like, I'm just being nice because like, oh yes, Victor, you're a great teacher, better than Eli for sure. So that's what I'm taking this as. Yeah, so I think honestly, a lot of it is a lot of practice. Again, I will highly recommend reading this section in the Python Data Science Handbook for this intro to NumPy. Like, if you can do this, you'd be like a NumPy master. You'd be like, yeah, I got pretty much all this stuff set. Note that you do not have to be that way either, but I think it does help you kind of influence stuff like this. And let's see here.